lesson 30 from geotrig, a continuation off of polar form, rectangular form, is I want you guys to be able to add vectors together. Polar form, guys, is just another way of saying a vector. Vectors, again, have direction and magnitude. So direction and magnitude, think of Despicable Me. Okay? Not Victor, vector. Okay? Direction and magnitude. Now, there are two different ways to put together vectors. You're going to add them, you're going to subtract them, that's part of it. But there are two different ways to state their answers. One of the answers is when you combine them, either by adding or subtracting, and you are asking for the resultant. The resultant, guys, is the combining of two vectors by addition. Remember, if you're subtracting, you can add its opposite. So you're going to just give me an answer when you add them together. The resultant is what it says. The equilibriant is the equal force required to negate the applied force. Basically, it's the opposite of the resultant. And it's not the opposite as in opposite sides, because it still have the same magnitude, it just won't have the same direction. So, if I am pushing a wall this way, in this direction, or pushing some object, a desk, a chair, a car, and it doesn't move, it's because that object is pushing back at me in the same exact direction and force. The car moves because my force is bigger than the force that is pushing back at me. That makes sense? Tug of war, right? The person who's pulling the hardest on the same rope, which is opposite directions, makes the rope go their way. In this case, when we're talking about forces, we talk about going in that particular force, that particular direction. So, equilibriants have the exact same magnitude or strength, radius, but one will be differed by the other by 180. So, what do I mean by that? So we may be going 3 at 60 degrees, right? An equal force to that, or an equilibriant force, would be 3 at where? What would differ by 180? 240. Wait a minute. Or, could I say this? Can I say 3, 120? So it doesn't matter how many times I go around the circle, but if it's in exactly at the end, 180 degrees difference, as in their coterminal angles, are 180 away from each other at the same point. They are called equilibriant forces. They'll basically, I'm trying to say the right word for it, cancel each other out. Okay? So your job sometimes is just to add them together, find the resultant. Other times you have to find the resultant, but it won't ask for the resultant, it'll ask for the equilibriant. So in that process, you find the resultant and then change the angle by 180. That's it. But wait a minute, guys. Would you guys agree that if I went 60 degrees, but I went backwards 3, isn't that the same as the bottom 2? You remember how polar form works. Doesn't this mean I go 60 degrees, but then I walk backwards 3? There I am right here. This is 63, 6, 3. This one, the bottom one, is 60, but walking back 3. Both of those have the same distance. They would cancel each other out if I was talking about vectors. So there actually are a whole bunch of different ways that you can give me the equilibrium. Sometimes it's just as easy just to change your I hat, j hats, or your magnitude to a negative magnitude. Your radius to a negative radius. So let's actually do this. It says find the resultant. If I'm going to find the resultant of these two vectors or polar forms, the question you need to ask yourself is, is 20 and negative 230 differ by 180? Because if they did, I could potentially just do 4 minus 7 or 7 minus 4, and I'll have an answer, right? One of them will be bigger than the other in exactly the opposite direction, so one will have more strength. But do they differ by 180? And the answer is no. So this is what I propose. I say you need to find their components, aka I want their I hat and j hat forms, because when I add numbers in rectangular form, I hats and j hats, I can take the x's or the i's hats and put them together. I can take the j hats and put them together. But here is the thing. We start off with polar form. They want the answer in polar form. So what you guys did in your homework, you have to do it once, both ways, here. You need to switch, or actually more than once. You need to switch to rectangular, and then take the rectangular, put them together, and then switch it back to polar. That's it. So it's just one extra step from what you had to do yesterday. Just all at once. So each one of these, I'm going to convert separately. 20 degrees, walking out 4. There it is. Obviously, it's not drawn to scale. That's okay. It's just a picture for us to get our information. Draw my triangle. There's theta. Actually, we know theta. What's theta? 20. What's r? 4. Bless you. We need to find x and y. How do I find x? Cosine. Cosine x, or not cosine x, cosine 20 equals x over 4. Or multiply both sides by x equals 4 cosine 20. Is that going to be a nice number, guys? More than likely not. But we have calculators to handle that. Let's go to 2 decimal places. What would that be? 2.36? 3.7. 3.7, sorry. 3.76. Is everybody okay with that? Well, we got to find y. So instead of using cosine, I'll use sine 20 equals y over 4 multiplied by 4. You're going to find that you're going to keep doing this over and over and over again. But y is equal to 4 sine 20, and I don't think that's going to be nice either. Let's go to 2 decimal places. We now have our x's and y's, or I hat and j hat. So this becomes 3.76 I hat plus 1.37 j hat. Do it again for the next vector. I'm going to pause the video. You guys can try this one on your own. First thing, graph. What quadrant am I going to be in? Second, why?
You start in the x-axis of the first quadrant.
Right. I got to go a negative 230 and walk out straight. Remember, guys, you can spin forwards or backwards according to where our angle is. If I create my triangle, we know we're going to walk 7 feet out, or 7 something, right? That's the magnitude. But what's the angle? It's not 230 now. It's not a negative 230. It's what? Why is it 50? Correct. 50. Because the reference angle's 50, and the cosine and sine of negative 230 has the same value as cosine and sine of 50. I'd rather use 50 than negative 230. Mr. Konchak, could I use negative 230? And the answer is yes. So, using the same exact logic, we got x and we got y. X would equal, can we do this without having to go through all the steps again? Shouldn't that be 7 cosine 50? Y would equal 7 sine 50. I'm just following the same pattern we did here. We started out with cosine 20 of x over 4. This would be x over 7, and multiply both sides by 7. Or 4 that time, 7 this time. 2 decimal places, sorry. What is 7 cosine 50? Alex? Tommy, can you back them up? Nick, are you going to back them up? Negative 4.5 is what I heard. Is that correct? Is it exactly 4.5?
No. 4.49.
4.49. Let's use 4.49.
No, it'd be 4.5 because it's round up.
Okay, we're going to round up. Okay, that's fine.
4.99.
Okay. Okay. We just got to make sure. I mean, I'd rather use 4.5, but we just want to make sure we're rounding. Because x is actually going backwards. That's how you get a negative 4.5, guys. Good question. X, if I did this, probably comes out to 4.5, doesn't it? But you need to recognize you're in the second quadrant. In the second quadrant, you're going backwards in the x direction, which makes it negative. Nick, stop. Y, 7 sine 50. John? That is going to be 5.36. Is anybody going to back them up? Okay. Thank you. So, we should have a negative 4.5 I hat plus 5.36 j hat. You guys all agree with this? Guys, we are halfway done. No. The thing about this is that I need to find the resultant. That means I got to add these. That's what it says up here. Add. So I'm going to add. I'm about addition between these. And if I do this, I just gather up like terms. I got some I hats. Oops, I forgot to put a hat on this. I got I hats and I got j hats. So if I take 3.7 I hat plus a negative 4.5 I hat, I get how many I hats? Negative 0.74 I hat. And a 1.37 plus a 5.36 j hat creates a 6.73 j hat. So has everybody got the idea that technically, guys, this right here is the resultant? You're not wrong. But because we started in polar form, I'm going to expect this in polar form. So now you just take what we just did on the board and convert it back to polar. Find r, find theta. Done. We'll take just the one answer. I made that smaller so that I can make sure we got enough room here. So I'm going to graph it. Negative 0.79 is about that. I don't know. I'm just going backwards on the x and going all the way up here on the y. I think everybody should agree that it's a taller triangle than it is wider. R is there. Theta's over here. We know that this will be negative 0.74. And we know 6.73. So, to find r, just use what's it called, guys? Pythagorean's theorem. But it's going to be of some crazy decimals. Let's just stick with 2 decimals, okay? This one is one of those few times that I'm going to say, because you're going to take a square root of a crazy decimal, that's 0.74. You're going to just use a crazy decimal, okay? All right. So 6.73 squared plus 0.74 squared equals, we'll get that number, 45.82. Make sure everybody tries to get there. Is that not what everybody's gotten? I got 45.292929. Something on those lines. Oh, which one is it? Is it 82 or 45.29? 29. I get more people saying 45.29. Make sure we can get there on our calculators. Make sure that if you have to, use parentheses. That's not right. Now I'm seeing people.
That's just the 6.73 squared.
Oh. Oh yes, we got to do both, guys. 45.84 for both of them combined. Good? Okay. Just want to make sure. Now square root both sides. Yes. R is equal to 6 point something probably, right? 6.77. Not so nice, right? But it's doable. That means the magnitude of your vector combined is 6.77. We got to find theta yet. Remember, theta is the inverse tangent of your ratio, and that ratio, who cares about negatives, 6.73 over 0.74. So it's about inverse tangent of around 9-ish probably, right? What do we end up getting? 6.73 divided by 0.74.
83.73.
Okay. Hopefully someone else can back this up. Okay. Now, let's just think about this. We know theta right now is in the second quadrant, and we're coming up with an angle of 83.73. Look at your diagrams. Think of 83-degree angle there. Does that make sense? I think it would, because you know it's a larger angle in the second quadrant over here. So this angle here is larger. Now, the right angle, or sorry, not the right, because it's not right as a 90, the correct angle that goes into the polar form is not 83. How do we find that angle again? Minus. So if you want to find the correct angle, you'll take 180 and you'll subtract these, and you end up with What angle? 96.27. So it's 96.27. Oh, not 72. 27 degrees is the angle or equilibrium, not equilibrium, well, resultant of those two put together. It takes a while to do, doesn't it? It's okay. Now, I have another problem up here. Okay? I'll go back to the other one. Don't worry. This one doesn't want the equilibrium, or the resultant, it wants the equilibrium. But guess what, guys? You got to do all of that to find the resultant. And then once you have a resultant, to get to the equilibrium, you just take the angle and add 180 or subtract 180. You're done. Okay? So, in this case, I'm going to ignore that actual problem. I'm going to put this on here and say, okay, we just did all that work. Give me the equilibrium of this problem now. Again, it will not matter if I add 180 or subtract 180 from this. But which one makes more sense? Adding. Why? It's a positive angle. Again, we like to have positive things. So if I take that and, add 180, I still would go 6.77 as a magnitude, but my angle that would be equilibrium, equal size but opposite direction, is what? Boom. So it's really a 30 or 10-second add-on to find the equilibrium more than the resultant. You'll always find the resultant. You'll only find the equilibrium. One equilibrium, right. You will only find the equilibrium if it asks you to. But if it asks you to find the equilibrium, then you have to find the resultant. Homework from lesson 30. I want you to take both pairs of vectors. I want you to find the resultant of each set. So if you want, call this one 1 and this one 2. And I want you to find the equilibrium, which again is that 10-second add-on. Okay? Have a great day.